Okay, so I hope everybody is ready for a deep dive in Laravel's encryption and its security flaws. So, better this way. Nope. All right. Okay, anyways, so who are we? We are Rémi and Mickael. We are security experts at Synactive. Synactive is a company specialized in offensive security. We have a penetration testing team, reverse engineering team. We do trainings. We also have a response incident team and a development team. We are around 180 experts around France, and we have 5 offices in Paris, Lyon, Toulouse, Rennes, and Lille. So if you are a security enjoyer, let's work together. So that's what we will talk about. So first of all, we start with a quick introduction to Laravel, its encryption mechanism. We'll see why Laravel is exposed to unserialized attacks and how we can use it with an app key in order to exploit them. After that, we'll talk about vulnerability research we made on a big Laravel project in order to try to spot such patterns. We will see 3 vulnerabilities on big Laravel projects and see how we can exploit them with a newly developed tool we developed recently. And after that, we will have a quick analysis on the app key quality in publicly accessible Laravel application, see what previous attacks in the wild were on Laravel encryption, how to find valid app keys, and finally the overall results we came from. Okay, so let's start with what is Laravel anyways. So Laravel is a free open source PHP framework designed for web application development. It can be used for a ton of usage, for example, to do a CMS, an e-commerce, etc., etc. It's really a big PHP framework, one of the most popular ones, if it's not the main one. And Laravel application often handle critical data, such as for e-commerce, some customer data, etc., etc. And so there are especially an interesting target for attackers. Around the world at the moment, if we believe BuiltWith, which is a reference to see how many websites are exposed publicly, there are more than 1 million Laravel instances at the time we are speaking now. So now that you a little more know what Laravel is, let's talk about its encrypt usage. Laravel simplifies the encryption through the encrypt function itself. It's based on OpenSSL library. And basically, when you have a package with Laravel, it will often be made with Eliminate, which is in fact just a bundle that you will use in Laravel. This one is used by default. And so the Laravel Eliminate encryption package works as follows. It will be loaded by default. So as you can see there is a way to use it. We have the string hello world, and we use the function encrypt in order to encrypt the data. Encrypt works in complementary with the decrypt function, and it's loaded by default. So if you are using a Laravel project, you just need to type encrypt or decrypt, and you don't need to put a use statement in order to load it. So it's pretty useful and dangerous. We will see why just a little later. Often, Laravel encryption is used as an integrity validator. So user data will often be used with the encrypt and decrypt function from Laravel. So now that you know what these functions are, that's how it's actually made. You've got this following base64 data. It's in fact a JSON object. And as you can see there, it's based in fact in AES CBC 256. It's by default, so we'll only see what is made by default. First, you have the initialization vector, which is generated randomly each time you are asking for an encrypted data. There is a value which is ciphered with the IV plus the app key. And you have also a validation MAC in order to prevent padding oracle attacks, which this kind of encryption were weak to before a certain patch. And finally, you also have a tag, but this one is not really interesting. It's used in other AES modes such as GCM. So now that you know how the encryption works, let's talk about a little security flaw in Laravel itself. Laravel contains a lot of gadget chains which can be used in order to exploit unserialization attack. PHP GDC is a tool which was created by Chartfall, which is maybe or not in this place right now. And it's used basically to craft unserialized payloads. So this tool also contains a complementary script which is called test-GDC compatibility. And as you can see, we can put some version of Laravel to see if they are vulnerable or not to gadget chains. And as you can see there, there is at least 8 gadget chains valid on the latest Laravel versions. And it's an issue because, as you will see on the next slide, Laravel does not patch the pop chains. They just keep them as they are. We asked them a few times to patch them. They won't. So don't work with unserialized on Laravel application. But you know anyways, Laravel core developers won't use unserialized, right? They won't use it on any function which is loaded everywhere. But as you can see on this little code, in fact, by default, when you decrypt data, Laravel encrypted data, they are in fact serialized data themselves. So basically, by default, you will work with serialized data. The value is ciphered with the app key from Laravel applications. And you know, basically that means that controlling database to decrypt plus getting your hands on the app key means you've got a remote command execution. So what is app key anyway? App key is the primary requirement to control decryption, as we saw. Without this key, we cannot attempt to exploit decrypt because there is a MAC validation, so we cannot really do some fancy things with the crypto itself. Laravel encryption is often used as an integrity check, which ensures the application data remains unchanged during storage and transport. So what that means is that Laravel tends a lot to give users some encrypted data. And so, as we will see, that's an issue. If you are looking for app key on GitHub or other locations, you need to have a look to inside 2 files. The first one is the current location of the app keys. It's inside the .om file. So there you just need to have your hand on. The second one, which is less new, was the previous location of app keys, which is inside config app.php. And as you can see, by default now, they are using, in fact, the .om variable in order to reach the app key. But you can still find some hard-coded app keys inside this file. And Laravel core developers also had a wonderful idea. It's the option app previous keys. You know, it's used in order to rotate your app key to make sure that, for example, if it leaked, that won't be a security issue. But however, app previous keys are used by default also inside your decrypt function. So even if you rotate your app key, if it leaked, you still are vulnerable to the decrypt flaw we will discuss right now. So, security best practice. You need to store your .om in restricted directories. Don't lose, because that's an issue we saw a lot of time on other projects on GitHub or whatever. Avoid exposing your .om in version control systems, as I said. And also, if you rotate your app key, don't put it inside your app previous keys. Really, don't use it for security. From a security point of view, it doesn't work, as we saw. And so app key is foundational to data confidentiality within Laravel, so don't let your app key leak somewhere, you know. So let's talk about the attack surface. In the past, Laravel cookies were serialized data. So there were a pretty famous CV during 2018 regarding data encryption inside your Laravel cookie. And so there are many ways to call decrypt. By default, your cookies are in fact ciphered with the app key, so you can try to brute force it. We will see that later. And anyways, the decrypt function can be used in other ways inside your cookies, your queues, or signed URLs, but they won't always embed some serialized data. And there is a blog post which details a lot better the attack surface, which was made by Timo Müller from Mogwai Labs during 2022. So it's still recent researches on it. So now let's talk about a tool we designed, which is called Laravel Crypto Killer. It's a tool we developed to manipulate / exploit this kind of vulnerability flow. There are 3 mods available. An encryption mod, which is used to mimic eliminate encryption encrypt function. A decrypt mode, which is the same but for the decrypt function. And finally, a brute force mode, which will try to test several app keys in order to see if there are default ones used on your cipher data. So now, that's the way the tool works. There will be a quick demo. All right, so basically, I have this little controller, which is called encrypt controller. As you can see there, there is an encrypt call in this way. There is also decrypt code, and so we'll try to see how we can exploit this kind of things. Basically, you have 2 routes, one to encrypt, one to decrypt, and we will see how it works just right now. So we made a little Docker compose environment in order to reproduce a lab. So we just wait for it to load. We go to our favorite navigator. We wait a bit. As you can see, it's on a Laravel latest version, which is 11.14, and it's on one of the PHP latest version, 8.3. As you can see there, we will encrypt the data. So yeah, with some typos, of course, but anyways. As you can see, that's our encrypted data, basically a base64 encoded JSON object. Now we will use Laravel Crypto Killer in order to exploit our decrypt function. And yeah, you need some time to see the tool, etc., etc. So there we need 2 things. The first thing is the encrypted cipher and the app key. To read the app key, you need to read the .env file if you follow. So we copy this app key, we paste it, and yeah, there was a typo once more. So anyways, as you can see there, we just need to put it this way. As you see, the decryption works. We see hello world, so we know that the app key is correct, right? Now we need one more thing to finish our exploitation. We need a gadget chain. And to do so, we will use the tool PHP-GC, which we discussed about earlier. We will put one of the numerous gadget chain with cipher back. And now we will pass it to decrypt. And voila, you've got a remote command execution to exploit a decrypt Laravel function. But you can say that that's something I made up. Nobody will make this kind of mistake on the wild, and everything is fine, right? Nobody will do that anyway. So now let's talk about our research on this type of pattern on big Laravel projects. So we searched about 3 main patterns. The first one was password with cookie serialization, which is basically a way to revive the vulnerability from 2018. Second one were some decrypt calls directly, which was the same pattern as the one we saw. And the last one is an option which is dangerous called session driver equals cookie. Basically, that means that you will serialize your current session inside your cookie because why not? So let's see the results. There are 3 CVEs, 2 are still remaining. There are not really identifiers on it, but they are patched anyway, so it will only take 1 or 2 more weeks. So the first one is on Snipe IT, which is 11K stars on GitHub, which one of the most Laravel used projects. And for some reason, they put back the option to cipher the XSRF cookie. And basically, they were still vulnerable to the vulnerability from 2018. The second project is Invoice Ninja, which had a pre-authenticated decrypt call, which is the same vulnerability we saw earlier. And the last one is Crater, and this one used to put your session inside your cookie directly. So now that we saw that, let's see how we can exploit them. After that, we will discuss the way to patch them. So yeah, the first one is on Snipe IT. This one is basically vulnerable to an old vulnerability from 2018 because they revived it by enabling the serialization of cookies inside the XSRF token. So we copy the cookie directly, which is Laravel encrypted. We will try the brute force option, this one. And so as you can see, there is also a default application key. So it's loaded inside the Laravel crypto killer, so you don't have to know any keys to exploit this kind of vulnerability. As you can see, there is cipher data. So basically, decryption, having the app key, plus having the cookie, we are able to get ourselves a remote command execution pre-authenticated because it's inside the cookie. So yeah, once more, we will use PHPGC in order to put a gadget chain inside this cookie. We change our XSRF token. We are not connected, right? And there you have a pre-authenticated remote command execution on SnapIT. So yeah, anyways, you know, that was just lucky. Maybe not. And that's the patch for this kind of vulnerability. As you can see, they just removed the option to put serialized data inside your cookie. So now they are safe. You just need to upgrade to the latest version. Now let's see with Invoice Ninja. So this one was based on a basic decrypt function call that we will see just after that. Once more, we use Docker. As you can see, we have our beautiful Invoice Ninja authentication panel. So now we need an encrypted data in order to see if we have the app key, right? So that's pretty easy. We just need to use a cookie from Invoice Ninja because basically they are Laravel encrypted ciphers. We once more try to brute force it with Laravel Crypto Killer. As you can see, Invoice Ninja also have a default app key. So once more, that's the same kind of vulnerability, right? We've got the app key. We've got a call to a decrypt function, which we will see a bit later. We put another gadget chain. I don't know if you noticed, but it's not always the same one because, you know, why not? And they have a pre-authenticated route. As you can see, we put our encrypted data, and we once more have a pre-authenticated remote command execution. Well, that's 3 of 3. Let's talk about the way to patch it. So basically, when we told them, they silent patched it, so thank you for that, if some Invoice Ninja developers see that. They just commented the route because I think they don't really know why this route was there anyway, so yeah, why not? They just commented it, so yep. Let's see the last exploit. This one is a little more tricky because it's based on a Laravel session cookie, which is not the same as the latest cookie we saw. So there, I don't know why, but we could not manage to load the front end from Crater, but anyways, backend was there, so anyways. As you can see there, this little base64 string is in fact your Laravel session. It works this way. It's once more an encrypted Laravel data. So we use Laravel Crypto Killer with the brute force mode because, as you can guess, there is also a default app key on Crater applications. As you can see there is an option on Laravel Crypto Killer called Session Cookie, which can be used to exploit sessions stored inside the cookies. So anyways, as you can see, there is an encrypted session right there, which is in fact a serialized data. We've got ourselves the default app key from Crater, and once more, we are using PHPGC with another gadget chain to exploit it. This time, you need to put a MAC inside the exploitation because otherwise it won't work. There is more documentation on Laravel Crypto Killer on GitHub if you want more details why. But anyways, as we will see, it works. So yeah, once more, we cipher our data. We set our Laravel session and enter, and that's it. We've got once more a pre-authenticated remote command execution. And so we try to say to Laravel core developers that, you know, app keys can leak, and they just, when we saw them, when we show them that might be an issue, they just said, does the vulnerability require the attack to know the app key environment variable? Yeah, it does. But anyway, some people will just copy-paste them anyway, so that's still vulnerable to this kind of attack. And just the last word, from character, you need to go back to invoice shelf, which is a fork to it, because character is still vulnerable to this kind of pattern. So that's it for me. I now let Mickael talk about the analysis we made on app key exposed publicly.
Thank you, Rémi. Thank you, Rémi. So yes, we are going to see the analysis of the app key quality in publicly accessible Laravel applications, so for facing the real world. So first of all, we start with perform attack during January 2024, but it's just an advisory from FBI. See all the malware made on the internet. So for the real world, the malware scanned the internet for Laravel application. So for identifying a specific Laravel, upon finding a Laravel application, it checks for exposed downtime file to steal credential and API keys, like Rémi said. And sometimes it may also send a post request with a specific variable to trigger an error for aiming to identify a debug mode for a Laravel application. So this can expose also credential and API keys on Laravel application. So if it's successfully, you access the application key and attempt to exploit the no remote code execution in 5.2 version with a XSRF token cookies. So information out from the blog post of Stephen Carter is informative for you. Okay, so first of all, we can talk about the use for an attacker. So what can be the most interesting way to exploit this for being behind all these security measures? So for the first one is to use the legitimate data with serialized app key. So an attacker with no of app key can bypass security check by embedding a payload in serialized data, because the data Laravel going to serialize and potentially executing malicious code. And like Rémi demonstrate, we have a PHP object with gadget chain, like using PHP GGC, can trigger arbitrary command without being detected by WAF because it's being unserialized and behind WAF, the web server executing it. So we have also a second point is important, is the minimal logging in default configuration, because deserialization and command execution may no leave trace in log, like a standard post request from a typical web shell. So it's important for us. So what we see here in this advisory or Androghost is just a visible attack based on decrypt, but we have a lot more of application and vectors for an attacker for a sneaky attack based on decrypt. So in Synactive, we want to analyze this from actual public faceness of Laravel application. So our objective is to assess the robustness of app key values as we use it in publicly available Laravel application by identifying vulnerabilities in keys. There are 2 weeks common or finding in documentation. And by that, make a good word list of app key for offline brute force with our tools. So the first tactics is to exfiltrate serialized object without interacting with a web server and collecting a serialized object from exposed Laravel application. And the second one is prioritizing a common target, like with a default app key or common weak app keys or values or GitHub project. So we're going to start it. So first of all, for finding tokens, we're starting by exfiltrate all Laravel cipher objects foundable on the internet without interacting with web server. It's important to us. So we start by the most famous one, the leveraging with Shodan for discovery, because it indexes publicly exposed server information, including Laravel XSRF token and any other cookie. But what we want is an object from a Laravel application. And from some of this pattern, we can use this matching query with set cookie XSRF token. First one is interesting because you had a lot of results. Or the second one you can use is about the debug mode of Laravel, which is in PHP title, HTTP title, sorry. So for the result, we have around 700,000 results, which is interesting. We have to go into filter for having around 600,000 results. But you see all these applications facing with common web port, and for most of all, we have a cookie with token, the capabilities to extract it. So this is okay for extracting how tokens. Now we try to find app key in the wild. So for this time, we also not need to interact with the web server. So this most important part is all this application facing web as vulnerable to brute force attack with targeting app keys. So we try with very simple dork, like GitHub dork, for identifying base64 encoded app keys. Google dork for identifying .env file have been exposed and indexes for also app env or app key. And we can also get some relevant app key from bad secrets. It's a naughty repository for app keys, but is not fully understandable for us because it's mostly focused on a Windows web server. You can also, if you are a smart person, grab .env from the web server facing internet like Shodan, but we don't do that here. We don't want to try to interact with the web server. Okay, and for this part especially, many .env are accessible across the web, so it's important to note how research is without interacting with the web server, but many environment configuration should remain private because .env still leak through Google and GitHub, sometimes due to accidental publication, but for most of all, it can be by default. And like Androgos do, you have a global scanning with word list attempting specifically to identify .env containing critical secret like app keys, like this following word list. Okay, what is finally the danger of default app keys? Because default app keys is in production environment, and when it makes application easy to target because an attacker can leverage an encrypted cookie like XSRF token by reverse engineer the key because sometimes the key is not a random string, gain access to sensitive data because if we have the key, even if it's not an RC, I can access to sensitive data encrypted with it, and compromise the system for the most important part, like we discussed before. And that's why the purpose of Laravel Crypto Killer to use the brute force method. So with how to Laravel Crypto Killer, you can use it to brute force app key. So you can use it with option cipher file. So that can be used to select a Laravel cipher value. And the brute force can be multi-threaded for making sometimes for optimizing your decryption, but it's not a brute force tool, so it can be more optimized at this time. But you can use it for making thread for brute force it. So we try it with how sample. So with Laravel Crypto Killer, you have just fewer information to make. You put the brute force parameter, put your cipher file, and automatically we have put a word list folder with our research inside the tool for making the most common app keys we have found on the web. And in our token, here is around 600,000 token. We have around 10 hours to brute force all of them with our word list. So after many hours, what is the result of our brute force? So here is a classic sample of your result. So you have the value, we have a cipher, the cipher we have. Also, if it's serialized data or not, it's especially important if we want to compromise the application, and the common use and specific information about the brute force made. So for how offline brute force of XSRF token and serialized data with our custom word list, the result we just made 4 brute force in a few weeks with default configuration, one simple pattern, and just quick doc inside them. We have found a way to set keys cracked in 6,000 application and around 400 application with serialized data. So it's free RCE without any interaction with web server. So it's pretty cool. So every change here in occurrence, we have 3 patterns very important to discuss, because it's the most occurrence. We have the 3 bad practice we have in Laravel management of app keys. So the first one is typical of developer using application and deploying it with default configuration, because we have an invoicing application with base 64 keys in default documentation in GitHub, deploying mostly without knowing what is his purpose. The second one is an occurrence frequently used in a bootstrap project. So it's a CSS framework used for many web applications, and is been deployed and forked in many projects. So that's why we have a lot of occurrence here. And the third one is bad practice of managing with app keys, is to use a non-random value with some random string of 32 char exactly, but in base 64 encoded. That is not satisfying, because it can be retrieved very easily. And also, you have the default app key on older Laravel version with some random string, or the most recent one with some random string with 32 characters. So what is the IOC application for that? Because here, a quick resume of what we found. So Laravel and XSF token cookies are publicly indexed on platform like Shodan, as we see. So this can be allowing a stealthy app key brute forcing without direct server interaction. And it's in common web port. So if exploitation we have, it's a lot more on the legitimate way. So with a valid app key, an attacker can exploit pre-authenticated decrypt code to compromise the server. So an offline attack is more stealthier than the type attack. So for resume of that, mitigation for Laravel is important to note. So when we want to use it, always generate strong and unique app key for all your projects with this specific command. Can irregularly audit application for weak and default app keys for applying a rotate strategy and being sure it's not deployed in many projects. Banish the usage of unserialized in any application based on Laravel for define less attack vectors, and use for manipulate string, encrypt and decrypt string instead of encrypt and decrypt is more secure for application. So, and 5N, the most important, restrict access to your available .m5 for being sure is not indexed or retrievable by an attacker on the web. So for the conclusion, first one, we have made our research to analyze decrypt function and its flow, like Rémi described in how few CV. The analysis of Laravel publicly exposed instance, token and key have been interesting, because in a few weeks we find a way to interact and find a web server to compromise without integration with it. So it can be useful for more research. And it can be an opportunity risk on the wide for many attackers. So actually, mismanaged app key pose serious problem. Because proper security practice has not followed. So you need to use strong and unique app key in all your Laravel projects. Regular audits if you have any .m5 exposed application with default app key or common web default configuration. And avoid relying on default setting on your web server. So for the last, file-read vulnerability will enhance the risk of future exploitation, because if we have a file read on this part, it can leverage on more attack vectors by reading .m5 and app keys. And we can make also an improvement for Laravel crypto killer on the brute force part for large scaling, but also an option to give to you the capabilities to audit directly your Laravel application by retrieving XSF token from URL or list and directly brute force it. Also, the improvement for our word list, so to optimize open source scrolling, because we have made this with pretty simple pattern, but we have a lot of more repository we can use for retrieving more app keys and secrets, and to update words for relevant brute force. And for the star, improvement for Laravel to deactivate using serialization by default, communicate about decrypt risk, and tailor, if you hear us, to patch blockchain. So thank you for your attention, and download the how-to Laravel Crypto Killer.
Thank you very much for the presentation. We have time for a few questions. Okay, I come.
1, 2.
No problem. Ask your question. Take your time.
Hello.
Hi.
I have a question about the range of the vulnerability. At how much do you estimate the range of the vulnerability? How many machines do you think actually run this CVE? Because we saw with the showdown slides that we have over 600,000 exposed IPs, but how many of them are actually vulnerable? Thank you.
Okay, so let's go back a little. Yep. So there are two things to take in consideration there. So the first one, as you can see there, Invoice Ninja was one of the most vulnerable to AppKey leak, like 152 leaks on on publicly exposed instances. There might be other, but which won't be exposed directly. And as you can see there, we did not recrawled it, during this month, but at the time there were 400 pre-authenticated remote command execution in the wild, and you can add any other default app key we identified on the 3 projects we talked about. So you can add any of them. Now they are patched, but anyways, there might be also other servers with Laravel sessions embedding some serialized data. So that's for sure, at least 400 pre-authenticated remote command execution. But there might be a lot more, in fact, because we could not dig inside any Laravel project and see any project exposed publicly. So if you are doing bug bounty or this kind of thing, you really should have a look. That might be useful.
Okay, we have another question here.
Actually, it's related to what you just said. Is with Shodan, you have a way to identify. Laravel website on some bug bounty programs. You have a way to list some endpoints. So using this, you can scan website under vulnerability disclosure programs or bug bounty programs. Did you try finding vulnerabilities in websites covered by bug bounty programs and participate in some bug bounty programs with your tools? Did you try finding?
Did we try with bug bounty?
Yes.
Not at all. So it's all open for you if you like, folks. We just wanted to have a look at the expedition. So.
Okay. So next question? No? Okay. So I give the speak to Florent for few technical information for the organization, and this will end the first session of GreHack.
Okay, thank you.
Thank you.